So you should have in front of you your specific heat and calories handout. It should look something like this. And what we're going to start with, before we talk about the math behind specific heat, before we do specific heat as a number, we're going to talk about specific heat as a concept. And I'm betting it's something that you already kind of know in your head, but we just haven't really put a name to it yet. So I want to start by just defining what specific heat is. And then once you see it in examples, you'll be like, okay, now I got it. Specific heat refers to the ability of a substance to gain or lose heat energy. We've been talking the last few days about heat and energy flow and temperature and all those good things. So this is kind of an extension of that. The best example that that you can really think about has to do with the beach in the summertime. So what I want you to do is kind of split this little part in half. And we're going to be looking at the beach. Specifically, we're going to be thinking about the land and the water. So draw yourself a little picture here. And then same thing, the land and the water, but we're going to be thinking about this in two different scenarios. We're going to be thinking about the beach at the daytime and then the beach at the nighttime. And specifically, I want you to look down. You should have a little chart down at the bottom of your notes that has specific heat values of everyday substances. The substance at the very, very top is water. Water has a really high specific heat value, 1 calorie. And again, before we talk about what that number means, all that means is that if you have a high specific heat, I'm just going to abbreviate that SH, it's hard for you to change temperature. It's hard for you to change temperature. So in other words, because water has a high specific heat, it takes a lot of energy to heat water up. It also takes a lot of heat energy to cool it down. So let's take a look at what that might look like. I want you to think about going to the beach in the daytime, one of those days where the sun is shining really, really, really bright. And let's see, here's our sun. And it's emitting heat energy to the surface. Specifically, some of that heat energy is going into the land, some of the heat energy is going into the water. Because water has such a high specific heat, we're going to see, yeah, the water's going to get hotter, but it's going to be a small increase in temperature. Yeah, it's going to go up, but probably not by very much. The land, on the other hand, sand, has a very low specific heat. And so what that means is that sand changes temperature easily. Sand changes temperature really, really easily. So think about if you've ever tried to cross the sand at the beach at a really, really hot day, you'll find that the sand is really hot. Like the sand could almost be blistering your feet. It's so hot, but the water isn't that hot. When you get to the water, it's actually really cold. So for the sand, we have a high or a large increase in temperature. You put the same amount of energy into the sand and the same amount of energy into the water, yet they change temperatures at different rates. You put some energy into the sand and the temperature shoots up really, really high. You put the same amount of energy into the water and the temperature just goes up a little bit. That's because it has to do with specific heat. Water, it's hard to change the temperature. Sand, it's easier to change the temperature. So that's thinking about the beach in the daytime. Let's start thinking about the beach at night, kind of when the sun has gone down. There's no more energy being put into the sand or put into the water. So let's imagine what would happen here. Water, we'll start there. Water still has a really high specific heat, which means it's hard to change its temperature. We're going to see, just like we saw a small increase in temperature over here, we're going to see a small decrease in temperature over here. The water's going to cool down, but it's not going to cool down by very much. That's because it takes a really long time for water to let go of that heat energy. Now the sand, on the other hand, the sand, because it has a low specific heat, it changes temperature really, really easily. So what we're going to see for the sand is we're going to see a large drop in temperature. The sand is going to very quickly and very rapidly cool off to a point where it's cooler over here than it is over in the water. So it's this discrepancy in substance's ability to gain or lose heat energy. So again, to recap, over here in the daytime, the sand with its low specific heat really, really shoots up in temperature because its specific heat allows it to change temperature easily. If you have a high specific heat like water, you're going to see a small change in temperature because it's really hard to change the temperature of things with high specific heat. You have to put in a lot of energy to get just a little temperature change. Over here at night, when the sun has gone down, there's no more energy being put in. We see a large drop in temperature for the sand because it's easy for sand to change temperature. The water, on the other hand, is going to hold on to that heat for even longer. So this is specific heat as a concept. What we're going to do with it next, though, is look at it as an actual number value. So specifically, specific heat relates to the amount of energy to raise 1 gram of a substance by 1 degree Celsius. The amount of energy to raise 1 gram of a substance by 1 degree Celsius. So let's think about that in context again with our beach example up on top. Because sand has a very low specific heat, it takes a low amount of energy to raise 1 gram of sand by 1 degree Celsius. In other words, you put in a little bit and you'll see the temperature jump up really quickly. With water, on the other hand, water has a high specific heat, so it takes a large amount of energy to raise 1 gram of water by 1 degree Celsius. You'll put in a lot of energy and still only see a small temperature increase. If you look, you have the table down here at the bottom. It's not on my notes, but you have it on your notes. And you'll see some common substances. Water has one of the highest specific heats of any substance on Earth. One of the highest specific heats on Earth. Not the highest. I think we've been able to make some in a lab that are slightly higher. But in terms of natural substances, this is as good as it gets. It takes more energy to change the temperature of water than it does to change the temperature of anything else. If you look on the bottom towards that list, you see things where it's really easy to change temperature. Metals, for example, traditionally have very low specific heats. You'll see things like aluminum or copper. And this is why you'll see cooking pots with copper, a thin layer of copper on the bottom. And that's because copper heats very quickly. You'll notice it has a low specific heat. That means it heats up really, really quickly. So it's very easy. Here, we'll add a handle to our pot here. It's very easy to change or heat up the temperature of a pot if it has some copper. You can also buy aluminum cookware or to go with those copper-bottomed pans. So the idea is that the amount of energy it takes to raise 1 gram of anything by 1 degree Celsius is related to its specific heat. Okay, so when you come to class, then we're going to add on to this idea by looking at some mathematical ways that we can work with specific heat as a number.